Hi, good evening. Good evening to everyone. Namaste. Vanakkam. Good evening to everyone. Welcome to Gate Academy. Love you all. Love you all. Haribhajan, good evening. Nidhi Yadav, good evening. Rahul Patel, good evening. Rahul Jaiswal, good evening. Sridharan, good evening. Good evening to everyone. Yeah. Is everything is clear? My sound and video, audio, everything is perfect? Hi. Munna bhai, very good. Perfect. Chalo, let us start. Let us start the session. So share this session to maximum people. Share this to maximum people. Hi Rakhi Dash. Welcome. Dear students, yes, it is under the digital electronics part. Yeah, I'm start karenge. Perfect. Chalo. Dear students, today what I want to start is some interesting topics which are newly added topics. Actually, what are the newly added topics? These topics are under the digital electronics part. Under the digital electronics part of instrumentation people, which is related to actually sensors subject. Actually the topic should be in the sensors. So sensors and industrial instrumentation, the topic should be related to this. So one is added. So the name of the topic is DAC. The name of the topic is what? DAC. So what is actually DAC? This DAC is treated as data acquisition system. Okay. So what is data acquisition? पहले आपको ये मालूम होना है what is data acquisition system. Yeah, in EEE also added. Okay, very good, perfect. So what is data acquisition? So this topic is purely related to instrumentation actually. In our reality, in our real time, whatever the parameters you are measuring, that may be temperature, that may be pressure, okay na? So that may be velocity. Love you, Srikanth, love you, thank you. How are you? Thank you very much for your love and everything. Thank you. Thank you. Just a shadow. Yeah. So data acquisition means what? In our real time there are certain non-electrical quantities. So those non-electrical quantities are going to be converted to electrical quantities by using our transducer. And this electrical quantity is going to be properly signal conditioned. Then after it is going to some display purpose, or then after it is also going for some digitization. Thank you very much. I hope all of you are enjoying my sessions of sensors. I hope all of you are enjoying my sessions of measurements also. Okay. So soon we are going to start other subjects, optical, process control, and if possible I will start microprocessors also for you. Okay. So once the completion of these measurements is over, we will start microprocessors also. Yes. Everywhere we are using Subhaya. Everywhere we are using. This is a data acquisition system, dear students. Subhaya. So this is a data acquisition system. All of you are able to see? This is the data acquisition system. I am talking, the sound is converted to electrical by using this particular signal conditioning. All of you are able to see this? This microphone is converting sound to voltage and that is giving to you. Okay. So I want to give the basic introduction of the data acquisition first. Let us start with the basic device of microphone first. In our class we are using this microphone. I think all of you are able to see that. Yeah. So this is a transducer. Microphone is a transducer which converts sound to voltage. थोड़ा ध्यान से सुनिए, ये lecture बहुत important है क्योंकि data acquisition can be applicable for many situations. See, for example, if you see the microphone, What a microphone will do? Microphone will convert sound to voltage na? Microphone will convert sound to voltage. Microphone will convert sound to voltage. So I will explain like this. So if you take a diaphragm, first let us take a diaphragm. Let us take a diaphragm like this. So this is the diaphragm. I think all of you are aware of the diaphragm. What is a diaphragm? Diaphragm is a pressure sensor. Diaphragm is a pressure sensor. Okay, so this is the diaphragm. So on this particular diaphragm, when you apply the pressure signal, on this particular diaphragm, when you apply the sound signal, sound is a wave. Am I right or not? Sound is a wave. Listen carefully. Listen carefully. So I am applying a sound. Sound is a wave. That wave is having pressure. Now that pressure is hitting here. Okay, na? So the pressure is hitting here. Then what happens? This particular diaphragm is going to have some bending moment. So that is X. So pressure is converted to displacement. Am I clear? Yeah, converted to displacement. Now this particular displacement, what I am doing, I will start with the basic thing. I am connecting this particular displacement to a capacitive transducer. I am connecting to a capacitive transducer. So now what happens now? This one is going to touch, this particular displacement is going to touch this particular capacitor plate. Initially the gap was D. Initially the gap was D. Now when this X touches here, this particular plate comes down. When this plate comes down by X, the new gap will be D minus X. As you know, capacitance is inversely proportional to DC from the formula C is equal to epsilon A by D. So C is inversely proportional to D. Am I right? So as the distance is decreasing, capacitance will be increasing or not, dear student? These are the two capacitor plates. If you observe, all of you listen carefully. If you observe, so this is the diaphragm. I think all of you are able to see this diaphragm. So this is the diaphragm. Beneath the diaphragm, we are having a capacitive transducer. Beneath the diaphragm, having capacitive transducer, and this capacitive transducer is connected to the signal conditioning. Okay, so this particular capacitive transducer is connected to the signal conditioning. Okay, so now this particular one, with the support of a cable, it is connected to an op-amp. It is connected to an op-amp. Even though I am giving a DC supply, but this capacitor is going to be changed, and that is connected to op-amp like this. So this is the op-amp network, and here I am using some resistor, and I am going to get V0. Okay, na dear students? So whenever, according to our basic electronics formula, Q is equal to CV, I is equal to dQ by dt, that is equal to C into dV by dt plus V into dC by dt. So even though we are using DC supply, for DC supply this component will be 0. Why? Because V is constant. But we are going to have dC by dt. Am I right or not? We are going to have dC by dt. Why? Because the capacitance is changing as a function of d na. So C is equal to epsilon A by D. This D is variable. This D is a function of X. Am I right? Is it audible clearly? Dear students, is it audible, Rocky? Yeah. So D is function of X. So when I say dC by dt, I can say this is a variable minus epsilon A by D square, and derivative of this will be d dash of t. Okay na? So this is V into dC by dt, dear students. All of you followed? So now the current whatever is coming, see all of you try to understand the data acquisition model. So whenever this particular thing is constant and this key C is changing with respect to time, and this particular current is going to come here, and this current cannot enter into ideal op amp. So the current passes like this, and here there is a feedback resistor. So I can write V0 is equal to minus I into RF na? Yes or not? V0 is nothing but minus I into RF, and this particular I is coming, because of this particular capacitance change. So if you observe this diagram, what are the blocks here? Now this V0 is going to be transmitted. If this V0 is going to be transmitted by using the transmitter, so this voltage signal I am transmitting, okay. So this is now a data acquisition model or not, dear student? Yes, I told data acquisition strain gauge also. So if you see this particular block diagram, what I have? First I have a diaphragm. So very beautiful questions can be placed here. Diaphragm output is connected to capacitive transducer. And the output of the capacitive transducer is connected to op amp, and the op amp output is called V0. So diaphragm converts pressure to displacement, and capacitive transducer converts that to change in capacitance, okay na? And that is given, capacitive transducer creates certain change in capacitance. So because of that some current is possible, and that current is converted to voltage. So here diaphragm is an example of sensor, and capacitive transducer is an example of transducer, and next one op amp is example of signal conditioning circuit. So all together this is what we call as a data acquisition system. Of course the final will be display. If you want to connect to the display you can connect. So this is what we call data acquisition system. All of you understood, dear students? Yes, correct. So what is data acquisition? Data acquisition, it is a process of achieving the information of a physical variable, in a required format. Do you understand, dear students? So this is the definition of data acquisition. Dear students, in our reality, ना भैया कितनी बड़ी बात कह दी. Okay, thank you. So what is this? Data acquisition is a process of achieving the information of a physical variable in a required format. So here what is the required format? I have taken the analog output. Okay, so I can take the data acquisition systems will be two types. One is the analog data acquisition system, analog DAC system, and other one is digital DAC system. All of you understanding, dear students? What is the fundamental difference between analog DAC system and digital DAC system? The only difference is here the output is only analog. In analog DAC system, the output is analog. In digital DAC system, the output is digital. How this particular digital data acquisition system is achieved? Digital data acquisition system is nothing but analog data acquisition system analog data acquisition system plus ADC. ADC is attached. So here you should have some basic knowledge of ADC about the digital data acquisition system. Let me take one diagram so that I can explain you neatly. See, for example, if you take a cantilever beam, so this is our cantilever beam. Okay, na? On the cantilever beam, we have kept a strain gauge. So this is our strain gauge, and this particular strain gauge is going to be placed as a part of, listen, this particular strain gauge is going to be placed as a part of Wheatstone bridge. So this is a part of Wheatstone bridge. Listen carefully. So this is attached to a Wheatstone bridge and this is our supply voltage. Now the output of the bridge connected to op amp which is having certain gain. This output V0 I am connecting to ADC chip. This ADC is having some V reference voltage, मजा आ रहा है? And the output of ADC digital, this digital output is connected to, if you are satisfied with this, you can directly connect this to a 7-segment display. A 7-segment display. You can connect this to a 7-segment display like this. Or if you want to further extend, what I can do here, I will connect this particular digital output. Dear students, listen carefully. In the digital electronics syllabus, dear students, listen carefully. In the digital electronics syllabus, have you observed? In the digital electronics syllabus, for instrumentation people, these 3 topics are added. One is the microprocessor, microcontroller and PLC. Yes or not? So these are the topics especially which are removed for ECE. ये ECE लोगों को नहीं है लेकिन हमको है. So that is a beauty. Okay. So what they have done now, so this particular output, ADC output, I will connect to a particular microprocessor chip. I will connect to a microcontroller chip or a microprocessor chip. I can connect this to a 8051 microcontroller. And in this particular 8051 microcontroller, I can write a assembly language program. Like move, add, something, and the output from the microcontroller is digital. So this digital output of the microcontroller I can connect to a 7-segment or any other system. So microcontroller output is digital. So this, if I connect to a DAC, the DAC will convert, ADC is converting analog input to digital output. So this will convert into a analog output voltage. This particular voltage I can connect to a electric actuator. This voltage I can connect to some electric actuator. So that electric actuator will convert this electrical signal into mechanical signal. Okay na? So that mechanical signal again I can connect to process. So this is my process. So where I am applying the force here, so here I am applying a force here. Okay. So this particular mechanical signal, this particular mechanical signal again I can connect to process. This particular mechanical signal I can connect this particular mechanical signal to the process. All of you understood the student? Maza aaya? Yes. Yes. All of you understood now? So that is connected to a process. So like this, the digital data acquisition, basically actually it is data control, but only up to this we can call it as digital data acquisition. Now if you see this particular diagram, in this particular diagram what blocks we have? First we have a sensor. In the place of sensor I have taken a cantilever beam. The input I am applying is the force. On the sensor we are having a transducer. The transducer is nothing but strain gauge. The strain gauge output is connected to Wheatstone bridge. Wheatstone bridge output is connected to op-amp. So if you stop here, this is going to be analog data acquisition system, but once you attach ADC, you are going to get digital data acquisition. This D0 to D7, you can connect to microprocessor, you can connect to PLC, okay na? So this D0 to D7 can be connected to what block? It can be connected to microprocessor, or it can be connected to microcontroller, or it can be connected to PLC, or it can be connected to 7-segment display also. 7-segment display also. Dear students, all of you understood now? So now if you see, this particular thing is all analog signal conditioning. So this all is analog signal conditioning. So this analog signal conditioning, of course ADC is also attached, then it is becoming digital data acquisition system. What is the beauty of digital data acquisition? Which is more accurate? Which is more accurate beta? Which is more accurate? In analog data acquisition system, digital data acquisition system, which is more accurate? Low accuracy for analog data acquisition system, and here digital data acquisition will be having more accuracy. Am I right or not? So digital data acquisition system is having more accuracy, so we can send the data over long distances. Okay. So many questions can be formed now here. So what type of questions can be asked on the digital data acquisition system, you can understand. He can ask you the question at any level. He can ask you the question at any level. Okay. All have understood? He can ask you the question at any level. So let us take one question. Let us take one question, dear student. Let us take one question so that what type of clarity of questions you may expect, let us take. Yeah, if you see this question, this was asked in one of the previous GATE exam. This was asked in one of the previous GATE exams. I think already we have discussed. There is a push-pull capacitive transducer. The push-pull capacitive, yes, there should be sample and hold. I will discuss that. ADC के बारे में detail discuss करेंगे. Yes, sample and hold is required. Yeah, listen. So if you see this, a push-pull capacitive displacement transducer interface to a differential amplifier and an ADC. So this is the best example of DAC system. Okay, na? So this is a data acquisition system. Note that the bridge supply and the analog reference input for the DC, for the ADC, are derived from the same 10 volts DC source. Okay, na? So the change in capacitance for the full scale displacement is plus or minus 5%. So change in capacitance delta C is equal to plus or minus 5% of C. The gain of the differential amplifier is asking for utilization of full range of ADC. So how to solve this question? To understand this question, first let me take some information of ADC. So this is our ADC. ADC converts analog input voltage to digital output voltage. Okay, na dear students, digital output voltage. Okay, first let us solve this question first. He has given a bridge circuit. In that bridge circuit there are two capacitors. So this is C minus delta C. This is R, and he has connected here a DC supply. He has connected here a DC supply of 10 volts, and this particular thing is connected to op amp. This particular thing is connected to op amp like this, and the op amp is connected to analog input of the ADC. Okay, na dear students? Who is this Patel? Yeah, listen. So what is this V bridge now? So if you see here, this is a minus and plus. How to solve this circuit? This is plus, this is minus, and interestingly for this particular ADC is having some V reference voltage. The V reference is connected from the same DC supply. V reference is connected from the same DC supply. So now if you take the V bridge, can anybody answer? So these two capacitors are in series. So the current I is going to be divided here, I1 and I2. So these two capacitors are in series and these two resistors are in series. So the voltage across this particular capacitance is equal to, I can write V bridge is equal to V plus minus V minus. So if you apply the voltage division rule here, opposite capacitance is C plus delta C by C plus delta C plus C minus delta C into supply voltage V minus R by R plus R. So now if you write this, this will be simplify C plus delta C by 2C minus 1 by 2. So if you simplify, you are going to get this V bridge as V into delta C by C. So this is a V bridge. So easy to remember, this is just like a D.Sathish bridge, two capacitors in push-pull configuration. Yes. Yes, G sir, you will also teach PLC and DCS for instrumentation students. See, those topics are added in the digital electronics. Once all these my sessions are over, I will give you the guidance about that also. So Vs by 2 delta C by C, I have observed this particular output is connected to op amp. This op amp is having certain gain beta and the V0 is coming. So this V0 is equal to beta into this V bridge. So this V bridge is given here. So V0 is equal to beta into Vs by 2 into delta C by C. So this is the output of the bridge, output of the op amp. All of you understood? Now question here is, what is the beta value? Beta value is asking, supply voltage is 10, delta C by C is nothing but we got here, delta C by C is plus or minus 5%. If you see the question, the change in capacitance for full scale displacement is plus or minus 5% for the capacitors. So delta C by C is equal to plus or minus 0.05, but gain cannot be negative, so you can take 0.05. So that will be 0.05. And V0 is how much? That is a beauty. Can anybody tell me what is a V0? If you want to find out the beta, you should know V0. Dear students, see the question. This is the way he asked the questions. Ananja Bose, Rahul Jaiswal, Raki, other students listen. Data equation means you don't expect theory questions. Data equation means he will attach a signal conditioning. He will take a transducer. Transducer is connected to the bridge. Bridge is connected to op amp. Op amp में different categories है, different circuits है, and the op amp output is connected to something, and he will frame a question. As an integrator, he will frame a question. Sometimes he can attach to the microcontroller also. On microcontroller programming also he can frame a question. Okay, so don't think only theory questions will come. Now what is a V0? If you see the question, he is asking the gain of the differential amplifier for utilization of full range of ADC. That is the beauty of this question. For utilization of full range of the ADC. Full range of the ADC. The ADC is working in full range. So the ADC is working in full range. What do you mean by full range? Dear students, listen. Let me explain. Every ADC converts some analog input to digital output. But what is the range of ADC? That is decided by V reference. So analog input range will be what? The analog input range will be 0 to V reference. Do you understand, dear students? 0 to V reference. So if you take the ADC input, this is the input. So let us take the minimum input and maximum input. So this is the analog input and this is the digital output. So for minimum analog input, that is 0 volts, and ADC digital output will be what? How many bits? Suppose if it is a 8-bit ADC, if I have taken a 8-bit ADC, it will be 8 zeros. In hexa, this will be 00 hexadecimal. The maximum analog input is nothing but V reference. V reference matters. Suppose if the V reference is 10 volts, then it will be 10 volts. Ante this particular ADC is in a position to convert the analog input voltages between 0 volts to 10 volts. So 10 volts, the maximum digital output will be all ones. That will be FFH. All of you understood? So how much digital output comes, that is purely dependent on this V reference. If a V reference changes, suppose V reference changes to 15 volts, then this range changes from 0 to 15 volts. And resolution of ADC, value of resolution of ADC is given by one formula, that is V reference by 2 power n minus 1. So that is the digital resolution, V reference by 2 power n minus 1. Suppose if you are taking V reference as 10 volts, n is equal to number of digital output, that is 2 power 8 minus 1. So 10 by 255, that will be how much here? Can anybody tell me? 10 by 255. Can anybody tell me? Please summarize this 10 by 255. What is the value of 10 by 255? कैलसी है मेरे पास. $10 by 255. Please tell me. 10 by 255 value. फटाफट. कैलसी. It is coming 0.039. Okay. So 0.039, don't round off, take like this. 0.039 volts means what? That is a minimum analog input that can be convertible. That means if you take the steps of this particular ADC, if you take the ADC particular steps, okay, so if you take the ADC steps until the first analog input, this is the analog input, this is the digital output. So your input voltage is 0, then digital output will be 0. Input voltage is 0.1, 0. Input voltage is how much? Suppose input voltage is increasing by 0.039. Input voltage is increasing by 0.39, 0.039, until that there is no change in the digital output. So here comes a digital change. Here comes a digital change, the first step. The next step again 0.039, next step comes 0.078. So here comes another step. Next comes, so up to this it will be in the 0.039 volts. So that means what? It is the first digital output 0, 0, 0, 0, 0, 0, 0. Next digital output 0, 0, 0, 0, 0, 0, 1. Next at 0.078 again a change is going to happen. So that will be 0, 0, 0, 0, 0, 0, 1, 0. And next again it is going to be in this mode until the next step. The next step, if you add 39, so 0.1. 117. So next change is going to happen again like this. So for every change it is going to change like this. Do you understand, dear students? Do you understand, dear students? All of you understood? So for every increment of 0.039, the least significant bit of the digital output is going to be changed. The least significant of the digital output is going to be changed. Like this. The ADC is going to convert analog input into digital output. All of you understood? Yeah, sorry for the late. Okay. So, of course, anyway, in this question, the question is not about resolution, but the ADC ka maximum input kya hai? So, ADC full range, suppose if I am mentioning it, ADC is working in full range, ADC is working in full range, means its analog input will be what? Its input is equal to V reference na. ADC is working in full range means its input is equal to V reference. So in our previous question, what he has given, the utilization of full range of ADC has mentioned. That means ADC is working in full range. ADC is working in full range. ADC is working full range means what is the input? Input is nothing but V reference. If you observe the V reference, what is the V reference? V reference is derived from the same 10 volt source. V reference is derived from the same 10 volt source. So we can take V reference is also 10 volts na. So V reference is 10 volts, then V naught is equal, and V reference is 10 volts. This V reference is the input for, all of you understood. So ADC input is full, ADC ka input is full range of the ADC is nothing but V reference. So ADC input is 10 volts, ADC input is nothing but op amp output. ADC input is nothing but op amp output. Do you understand this logic? All of you understood this logic? So such type of logical questions will be asked, Munna bhai. Such type of logical questions will be asked. ADC is working in full range means ADC is taking the maximum analog input. It is taking the maximum analog input. The maximum analog input for ADC, the ADC input is coming from op amp output. So indirectly op amp output is V naught is equal to 10 volts. Now if you solve this question, V naught is equal to 10 volts, beta we don't know, Vs is equal to 10, delta C is equal to 0.05. So now if you solve the beta value, you are going to get the differential gain of the amplifier is going to be 40. All of you understood, dear students? Differential gain of the op amp is equal to 40. Maza aaya? It is plus minus 10, no, it is plus. It is plus. It is plus, it is plus. ADC analog input V reference is positive, okay, plus 10 volts, okay na, and the gain also it cannot be delta C by C plus or minus 0.05. Question asked is beta, so beta should be gain should be positive na, gain should be positive. Do you understand, dear students? Clarity aaya, maza aaya? So that means how much? Yeah. Thank you. Sure. I am a certified PLC engineer. I can guide you, don't worry about that. Okay. Chalo. All of you understood now this question. Now if you see here, yeah. Now if you see this point, so answer is 40. Next question. If the supply voltage to the bridge decreases by 5%, supply voltage to the bridge decreases by 5%, then the sensitivity of the measurement system is dash. Supply voltage to the bridge decreases by 5%, then definitely, suppose if you don't take ADC, dear students, all of you listen carefully. So this is the output of the system after the op amp na. So if you take this expression once again, let me take this expression. So V naught is equal to beta into Vs by 2 into delta C by C. Am I right? So if you see this particular expression, so this is the change in capacitance is the input and this V naught is the output. So sensitivity of the system is equal to what? V naught by delta C. Why? Because output by input, that is going to be beta into Vs by 2C clearly. So here sensitivity expression itself is dependent on Vs. If Vs decreases by 5%, as a Vs is decreasing, obviously the sensitivity also decreases by 5% na. Yes or not, dear students, following or not? Rahul Jaiswal? Okay, so here Vs is decreasing by 5%. When Vs is decreasing by 5%, the sensitivity of the system is also going to be decreased by 5%. So what is the answer now? The answer is what? If the supply voltage the bridge decreased by 5%, sensitivity of the measurement system is dash. What is the answer? I am expecting the answer from you. Nidhi, if the supply voltage the bridge decreased by 5%, then the sensitivity of the system, option A, B, C, D. Please tell me the option. What is the correct answer? Already I have written. So what is the correct option? Tell me. Yo, output V naught is equal to beta into Vs by 2 delta C by C na. So V naught by delta C is the sensitivity na. Beta into Vs by 2 into C na. So if Vs reduces, then definitely sensitivity reduces na. So what is the correct answer? Yeah, people are saying A, very good, but it is wrong. Dear students, A is not the correct answer. Why? Because when he mentioned the system, it includes ADC also. When he mentioned the system, it includes ADC also. So this is without ADC beta. This is without ADC. Okay na? See, in the question he asked the sensitivity of the system. Sensitivity of the system, this is without ADC na. You have not considered the ADC part. This is without ADC beta. This is without ADC. Am I right? Yes. Obviously, if the question is without ADC, thank you very much. Obviously, if the question is asked about without ADC, then the answer is correct. Nidhi Yadav, other students, Rahul Jaiswal, I am answering to you. If the question is asked sensitivity of the system without ADC, sensitivity of the system without ADC, then your answer is correct. But when you mention the system, it includes ADC na? It includes ADC. So what happens to ADC? Let us see again. What happens to ADC? Let us see here. See, dear students, all of you understanding what I am saying, all of you understanding? In this question, the sensitivity reduces by 1% is correct if the without ADC. But if ADC is considered, what happens? Dear students, listen carefully. So, first, what is analog input? 0. Digital output 0. What is the maximum analog input? 10 volts. Then the digital output FFH. Now answer me. Suppose the same thing, if supply voltage reduced by 5%, if supply voltage reduced by 5%, in this question have you observed? In this question have you observed? The V reference is derived from the same supply? Yes or no? Yes or no? Yes, tell me. Who is this? Fire alarm and elevators. Okay. So if the supply voltage reduced by 5%, this is reduces by 5% means how much? 5% it becomes 9.5 volts. It becomes 9.5 volts. When this is 9.5 volts, this V reference is also 9.5 volts na. Dear students, tell me yaar. Have you observed the V reference is derived? V reference is derived from the same supply voltage na. Who is this? Who is this cow? Who is that fellow? Please retrace that comment. Don't disturb the class. Okay, right. So, have you understood here? When the supply voltage reduces by 5%, this 10 volts becomes 9.5 volts. If this is 9.5 volts, automatically V reference also 9.5 volts. Then the range of this ADC will become, the range of ADC now has been changed now, dear students. the range of ADC now is equal to how much, Nidhi? Now the range is 0.9.5 volts na? Yes or not, dear students? Now listen here. The range is 0 to 9.5 volts. So now what happens? If I am taking this particular range, this is the analog input, this is the output. So now this is analog, this is digital. So what is the minimum analog input now? 0 volts. What is the maximum analog input? Please answer this question. What is the maximum analog input now? Why? Because when supply reduces by 5%, this maximum analog supply reduces by 5%. Here supply reduces by 5%, then V reference reduces by 5%. If it become 9.5, there V reference also 9.5. So what is the V reference now here? So V maximum, that is 9.5 volts now. Yes or no, dear students? Yes or no? Previously the range was 0 to 10 volts, now the range is 0 to 9.5 volts. When what is the digital output? Minimum will give you minimum output. Minimum analog input will be converted to minimum digital output. Maximum analog input will be converted to maximum digital output. That means again you are getting FFH only na. Again you are getting FFH only. Why? Because this ADC is working in full range. When the ADC is working in the full range, previously the full range was 0 to 10 volts, then the digital range was 0 to FFF. Previously it was 0 to 10 volts, then the range here was 00H to FFH. Now the range is changed to 0 to 9.5 volts and the ADC has adjusted the scale to 00 to FFH. समझ में आपको? Now previous full scale value 10, digital output FFF. Now the present full scale value 9.5, digital output same FF. Is there any change in the sensitivity of the system? Now tell me, is there any change in the sensitivity of the system? Do you understand my question, Nidhi Yadav? Do you understand my question? Munna, Raki, do you understand my question? Previously, whatever the digital output you got, now the same digital output you are getting now. So there is no change in the present digital output. Why? Because what is changing is range is changing. Bhanusri, the range is changing, but the digital output pattern is not changing. Have you observed? See here, 0 to 9.5 volts range if you observe, and previously 0 to 10 volts output if you check, there is no change in the digital output na. There is no change in the digital output. Yes or no? There is no change in the digital output. That's why, what is the correct answer, dear students? What is the correct answer, dear students? Now tell me, A, B, C, D mein, what is the correct answers? Tell me fast. No change. Excellent. That is a beautiful question. Beautiful question. Does not change. A is not the correct answer. Okay, na? This is the beauty of data acquisition system. My dear students, I want to talk to you related to resolution. So if you see the resolution, previously I was talking about resolution, right? So if, see here, what is the resolution of ADC? Resolution of ADC is V reference by 2 power n minus 1, 10 by 2 power 8 minus 1, that is 10 by 255, 0.039 volts. What is this 0.039 volts? This is the minimum analog increment, minimum increment in analog input, minimum increment in analog input, minimum increment in analog input for ADC, which can create a modification, in LSB, least significant bit of digital output. Do you understand? So this is the definition of resolution of ADC. Resolution of ADC बोलो तो क्या है? This is a ADC box. This is a ADC box. Here आपने analog input दे रहे हैं, आप इधर को आपको digital display आ रहा है. Now you are changing this analog input by something. You are increasing something, then the least significant bit is going to be changed. पहले कितना था? 0 0 0 0 0 1. Now 0 0 0 0 1 0. The least significant bit is updated. See this particular bit what we have discussed. That's what the least significant bit is going to be changed now. For every step increment of 0.039, the least significant bit is updated or not. For every change of 0.0039, the least significant bit is updated or not. Next, again the least significant bit will be updated or not. Like that it goes on, like that it goes on, goes on, goes on, goes on, goes on, goes on. So this is the 0, 0, this is a maxima FF. So this, if you connect, so this is the range of analog. So this line is analog, this line is analog, and these are the steps. Mazaya? All of you understood, dear student? Now, but remember, in this question, if suppose V reference, dear students, listen carefully. What we have to understand? If V reference is 10 volts, then resolution of ADC is V reference by 2 power n minus 1, that is 10 by 2 power, 10 by 2 power 8 minus 1, we got some 0.039. Okay, done. Now the V reference is 9.5 volts. If V reference is 9.5 volts, resolution of this same ADC will be how much? V reference by 2 power n minus 1, 9.5 by 2 power 8 minus 1. Can anybody tell me this value? 9.8, 9.5 by 255 कितना आ रहा है? एक बार चेक कर दीजिए बेटा. निधि यादव, please check it. निधि यादव, please check it. Yeah, 0.037 new, 0.037. Pakka? Sure? 0.037. See, have you observed the resolution value 0.039, the resolution value 0.037. That means what? If you see this previous diagram, now 0.037 means it will come front. So here itself your pattern will change, na? Next one will come at 74. Here itself the pattern will change, na? Do you understand? Do you understand? So what is happening here? The minimum incremental value, previously the minimum increment is this. The minimum increment previously was 0.039 and here the minimum increment is 0.039 nahi hai. The minimum increment is 0.037. Now the ability of the system to detect the smaller increment, that nature has been improved or not? Do you understand, dear student? The ability of the system to detect the smaller increment has been improved or not? Earlier my system was, you try to understand better like this, try to understand. Let us take in millivolts, bole to acha hota. 39 millivolts, this is 39 millivolts, this is 37 millivolts. So it is an advantage or disadvantage? It is an advantage or disadvantage? Please tell me first. Previously this ADC system was in a position to detect a smaller increment of 39 millivolts. Now it is in a position to increment of 37 millivolts. It is advantage or disadvantage? Your ability to detect the smaller increment is improved, na? Yes sir, improved. Its ability is improved. अरे भाई आपको पहले 39 मार्क्स आए तो पास मार्क है, 39 मार्क्स आए तो पास मार्क है. नया सिलेबस में 37 मार्क्स आए तो पास मार्क है. 37 is best ना, easy to pass. So ability to detect the smaller increment. Why? Because ये smaller increment कहाँ से आ रहा है? ये smaller increment कहाँ से आ रहा है बेटा? So the smaller increment in that analog input कहाँ से आ रहा है? The smaller increment is coming from the small delta C ना. Yes or not? The increment in analog input here, the increment in analog input. So this is analog voltage. The increment in analog input voltage is coming because of this delta C, and this delta C is coming because of some non-electrical delta C na. So your ability of increment in this is decreased. You are able to detect a smaller increment here means you are able to detect a smaller change in capacitance. You are able to detect a smaller non-electrical quantity. That means overall data acquisition system Overall data acquisition system, the ability of the system to detect the smaller increment in non-electrical input has been improved now. Previously, you are in a position to detect 0.39 centimeters, but now you are in a position to detect 0.37 centimeters. Do you understand? Non-electrical quantity. So there is a smallest increment in this non-electrical quantity X. Because of that, there is a smallest increment in delta C. Because of that, there is a smallest increment in the analog input voltage. Because of that, the least significant bit is going to be modified. Do you understand, dear students? Do you understand? Do you understand? That is a beauty. That's why the V reference has been reduced. Rahul Jaiswal, do you understand? In this problem, why he reduced this by 5%? Why he reduced by 5%? By reducing this, you can reduce this. By reducing this, you can reduce this. If you reduce this, resolution is going to be modified. When resolution gets modified, the ability of the system to detect the smaller increment. If you are instrumentation student, आपको पता होना है accuracy क्या है, sensitivity क्या है, resolution क्या है, threshold क्या है, range क्या है, आपको पता होना है ना. Now the system का performance has been best. Now the system is in a position to detect the smaller increments also. This is the beauty of data acquisition system. When you attach, see, did I change anything? Did I change the op-amp gain factor? Did I change the gain factor? No. Did I change any components in the bridge? No. Did I change any extra connections? No. Just by changing V reference, I am able to change the ability of measurement of non-electrical quantity. The performance of a measurement system not only depends upon the transducer, not only depends upon the op-amp rich circuitry, but also it depends upon the resolution of the final instrument. That is a conclusion beta. That is a conclusion I want to tell you. That is a conclusion. That is a beauty of digital. When you attach a transducer to analog, then to a bridge, then to a digital, you will understand that those people who have done the projects, you take a small non-electrical quantity like temperature, connect a thermocouple, you will get some microvolts, connect it to op-amp, you will get volts, connect it to ADC, you will get digital, then connect it to some microprocessor, start programming on it, then you will understand the beauty of instrumentation. This is what actual reality na. In every industry, this is only na, there is a pipeline. There is a pipeline. There is a pipeline. In this pipeline, a steam is going. This is a temperature T. For this, what I will do, I will attach thermocouples. Plus minus, plus minus, plus minus. So like this, I will attach thermocouples. Now all these particular thermocouples, I will connect in series, and the net output of this thermopile, I will connect it to op-amp, and the op-amp output V0, I will connect it to ADC chip. The ADC chip output, I will connect it to some digital controller like microcontroller or PLC. Now in this PLC, I will write a ladder logic programming. Like this. Do something so that whenever temperature is exceeding the limit, turn on a alarm. Whenever temperature is exceeding the limit, turn on a alarm. Such type of programs, if you want to write by simply sitting in an AC room, nobody is going into this boiler. To measure the temperature, nobody is going into the boiler. If you go to the boiler, you and your thermometer both will be smashed off. You are not going into the boiler. You are not entering into the pipeline. You are not measuring the flow rate by entering into the pipeline. Simply आराम से आप electricity room, AC room में बैठ के system पर आप programming कर रहे by using PLC. कैसा आ रहा है information? आपको ये digital information कैसा आ रहा है? आपको ये digital information कैसा आ रहा है बेटा? This digital output कैसा आ रहा है आपको? That is because of ADC. Transducer is the interface for real world. ADC is the interface for digital world. So ocean, instrumentation means ocean. Diamond of the diamonds, हीरा है हीरा. Okay, people don't know. Ship, EC, triple E, mech, when you go for work for industry, when you go and work for industry, you will know the beauty of instrumentation. Beauty of instrumentation. It will interface everything. Okay, dear students, I hope you enjoyed my session. Like this, when you interface, the actual beauty of transducer comes when you interface to the other subjects. When you interface transducer to bridge, measurements का beauty आएगा. When you interface transducer to a op-amp, measurement analog का beauty आएगा. When you interface this transducer output to ADC, digital का beauty आएगा. When this ADC output if you connect to PLC microcontroller, microcontroller programming का beauty आएगा. ऐसा है? All of you enjoyed the session. So upcoming sessions we'll plan some more topics, some beautiful topics. Okay, na? We'll collect some more objective questions. Why? Because the new topic, na? It's a new topic. Some people was Aranja Bose was telling sample and hold. Yes, correct. Before ADC, there will be a sample and hold circuit, SH hold circuit. So before ADC, a sample and hold circuit, and there is a sampling theorem here, sampling theorem. So these are some expected topics of communication. Sampling theorem says that your sampling frequency must be greater than 2 times of message frequency, measurement frequency. So these are our basic things of ADC. You have to know ADC working. In digital, in a full-fledged way, you will study that. You have to study. If you are going for industry, if you are going for industrial job, then you have to study ADC also. देख लूँगा भैया, देख लूँगा. थैंक यू. देख लूँगा मैं आपका टाइम, आपका शेड्यूल एंड आपका हमारा गेट एकेडमी का शेड्यूल की वजह से विल प्लान एवरीथिंग. डोंट वरी, विल प्लान ऑल द थिंग्स. ओके ना? सो दिस इज जस्ट इंट्रोडक्शन. I think now do you understand what is data acquisition system, everything. Now based on this, what type of questions he can frame? He can frame a question like this. He can frame a question like this. He can frame a question on ADC. He can frame a question on capacitive transducer. He can frame a question on Wheatstone bridge. He can frame a question on op-amp gain factor. He can frame a question on strain gauge. He can frame a question on cantilever beam attachment. He can frame a question on diaphragm. Many type of questions can be framed by using the DAC model. Okay, chalo, we'll meet at 9 p.m. I hope all of you enjoyed the session. Enough for today. We'll meet tomorrow another session. Okay, so please do like it. See, still this information is not going to spread. Okay, I am not I'm not a marketing person, right? I have to give I am interested in giving the beautiful content to you. Okay, so here we are giving a quality content, so please spread your mouth ka publicity. जो कुछ होता है आपका mouth publicity, whatever it is way, that is going to be a better option for you. See, in this present pandemic situation, for instrumentation you are not going to get anywhere this type of content. Okay, so please try to spread this type of news to all your friend circle, to colleges, WhatsApp group, Telegram channels, so that we are talking some interesting things. We are not talking any in the 1 hour duration. We are talking very interesting things and very useful things. Okay, I know the value of time. Okay, chalo, we'll meet at 9 p.m. Tata, bye bye, take care.